In this problem, we'll discuss problem number 1 from the simple harmonic motion problem-solving worksheet. Problem number 1 states if a particle undergoes simple harmonic motion with an amplitude of 0.18 meters, what is the total distance it travels in one period? We can use this diagram on the side to explain exactly what we mean by the amplitude. This position right here where they've stated x equals 0 is what we consider the equilibrium position. We can follow it all the way down through each part A, B, and C of the diagram. And you can see that we've called this position right here x equals negative A. So the distance from here to here is the amplitude in the negative direction. And we see the block is right here at the amplitude position, and it has a velocity of 0. This is the greatest distance that the block is ever going to travel to the left of the page. The spring force is in this direction as long as it's on the left-hand side of the equilibrium position. At the equilibrium position, the velocity is the maximum it's going to be. The force is equal to 0, so the acceleration at this point is 0. And the block is moving to the right. As the block moves past the equilibrium position, the spring has gone from compression to extension. The spring force is now towards the left, and the block is going to slow down and reach a velocity of 0 at x equals positive amplitude. So this distance here is the greatest distance that the block is going to travel in the positive direction. For a complete cycle of motion, the block must travel from negative A through the equilibrium position to positive A, back through the equilibrium position, and then again to negative A. If it's going to do that, it's going to travel, if this is x equals 0, and this is x equals positive A, and this is x equals negative A, then our block is going to travel 1, 2, 3, 4 amplitudes. So the distance traveled in one period, one complete cycle of motion, is always, for one cycle of motion, is always going to be 4a. So in this case, the distance will be equal to 4 times 0.18 meters, and that will give us an amplitude of 0.72 meters traveled. And that is the answer to number 1 on the simple harmonic motion problem-solving worksheet. Thank you.